Welcome to part 5 in the Rymar training series. This is going to be advanced skimmer modeling with Hydraflow hydrographs. So previously we have talked about how to understand the basic skimmer design based on volume for sediment basins. We've done advanced sediment basin design with SEDCAD and how to model skimmer in SEDCAD. And last time we went over using skimmers for permanent use and went through a case study there. We're going to now go through how to do advanced skimmer modeling with Hydraflow hydrographs. Hydraflow has become one of the more common modeling software now that it is part of Civil 3D, and so it seems to be pretty common with most engineers, or at least a lot of engineers. And then future topics are going to include advanced skimmer modeling in HydroCAD. That is a very similar program to Hydraflow, but it's got some benefits, especially when it comes to using the Marlee Float. We're going to then focus on water quality and talk about volume-based versus filtration-based water quality, and then water quality modeling, actually how to go through and model, run the calculations and do the modeling for filtration-based modeling, provide a design guide. So this is going to be based on a site that I actually did the engineering on several years ago. It was a site in a jurisdiction that required quantity control during construction, so a little bit different than most times with a sediment basin, but it's a good example of how to model a skimmer in Hydraflow. So this was our site. It's about a 5.25 acre site. There's about 3.4 acres here that was not being developed. There's about 2.25 acres here that was being developed. We're putting in a sediment basin in this corner, which is also acting as a detention pond. So the disturbed area drains to the basin. The undisturbed area is going to bypass the basin, and we're going to flow over here to study point C, which is across a small road. So we're sending water across this road in this case. So pre-development, we had, again, 5.5 acre, 5.53 acres. It's wooded, curve number of 59 as far as our existing condition, and time of concentration came out at 18.5 minutes. I won't go through TR55 in this case, but if you have questions about that, please reach out to me. We can help with that too. But anyway, time of concentration, 18.5 minutes. And then our post-development, the portion that wasn't being disturbed, basically staying the same. And the post-development portion that was being disturbed, 2.25 acres. Again, this was during construction, so we had a curve number of 86, which is kind of a bare earth with a clay soil condition here, and a time of concentration down to 7 minutes. So one of the keys here in modeling the skimmer in Hydraflow is when you build your pond, you've got to give it a data point to put the flow in. So what you're going to do is your stage elevation area table. We're going to recommend that you have a 0, a 0.1, 0.3, 0.5, and then a 1/2 foot up to whatever the top of your pond is, or at least to 4 feet. Or if your pond doesn't go to 4 feet, that's fine. Stop it short of that. But that will give you a place to be able to put in your skimmer flow based on what the flow rates are on the details. So again, each detail is going to have the flow rate for each skimmer with each orifice configuration for that skimmer. So in this case, we're looking at a 4-inch skimmer, and it's got the flow rate for 3.5-inch orifice, 3-inch, 2.5, and 2. So if you look at this blow up here, we give that to you at 0.1 depth, 0.3, 0.5, then every 1/2 foot up to 4 feet. And we also give you an average, but really you're not going to use the average for this because you're going to model that flow rate curve into the software. So you're then going to build your outlet structure. Your outlet structure, your A is your barrel or your pipe going out of your pond. B, we don't have in this case. Let's say we maybe played with some things in the trial error, tried something but didn't end up using that. Or B might be your low flow orifice if you weren't using the skimmer, so it'd be something down at the bottom of the pond. In this case, we have an orifice C, which is a 6-inch round orifice. It is 1.75 feet above the bottom of the pond. See the invert of the barrel is 958, and C here is 959.75. Our riser structure is at 3.6 feet in 961.6, so that's 3.6 feet above the 958. And we have a 1 foot rectangular weir cut out of the riser at 961. Now the magic here for the skimmer is to use the user-defined column. So this user-defined column here is where you manually plug in the flow rates of whichever skimmer you've selected and whichever orifice configuration you've selected to build in that flow rate curve into Hydraflow. So again, use this user-defined column here and just manually enter in the flow rates in CFS off of the detail. Blow up here the table, you're going to see once you enter that, your total outflow here at 1 foot 1.5 is equal to the skimmer flow. You get up to 2 feet, now that 6-inch orifice is kicked in, so you're getting a little bit more, and so on. Now, if the basin is over 4 feet deep, you can either just use the flow rate at 4 feet. If it's only, say, 5 feet or 5.5, that's fine. If it's much more than that, you might want to start extrapolating out based on the last 3 data points. Or you can use our Excel design tool that we went over previously and plug that in to give you a more accurate flow rate at deeper pond depths. If that doesn't make sense on how to do that, get back to me and I'll explain that in more detail for you. So then when you go in Hydraflow here, you got your schematic. Normally you're going to have a low flow orifice down here at the bottom. You're not going to see that in this case because that user-defined flow is going to take place of that. But here we see our 6-inch orifice, our 1 foot weir, and our top of riser. And if you look at the stage discharge curve coming out, this first flow up to the 1.75, that is our skimmer flow. Then our 6-inch orifice kicks in, our rectangular riser kicks in, and our spillway kicks in. You can kind of see each step along the way there. And then here, the green line's a little hard to read, but that green line here is your skimmer flow. So you can see it's a pretty small percentage of the overall flow, only going up to less than a half a CFS in this case. And again, if you look at your table, outflows, again, up to 1.5 feet of depth, the user-defined flow is equal to your total outflow, and then above that is your other things kick in, so you know that Hydraflow is calculating it correctly. So in this case, when we finished running this, our 2-year storm ran at a 2.33 CFS. To your post-development storm was 2.48, so we had a 0.15 increase, which we were allowed to go with that slight of increase. And then our 10-year storm, pre was 9.5, post was 9. So that is a very quick summary of how to model a skimmer in Hydraflow. Again, we're not intending here to do a full Hydraflow tutorial, basically just focusing on how to model the skimmer. So please check back soon with us. We'll have the HydroCAD and other versions up as well. Thank you for listening.